This is chemistry practical number 7. You're going to use chemical test to identify the ions in a single ionic compound. Now, when we mean an ionic compound, there's going to be two parts. There's going to be the positive part, which is the cation, and the negative part, which is the anion. So, positive ions are going to be metals, and that's what we're going to look at first. Now, in your booklets, it will say to use a single loop of nichrome wire. And I'm going to show you one example with the nichrome, but then I'm going to show you the way that we tend to do them in schools, which is using a splint. So here we have a copper compound. Now we know this is copper. Open the bottle, and you're going to put your Bunsen burner on the heating flame. Now, with the nichrome loop, you're going to get some of your compound onto your nichrome loop, and you're just going to place it above the cone of unburnt gas. That's the hottest part of the Bunsen flame. And there we can see straight away a fabulous green colour. Now, for the rest of the practicals I'm going to show you, I'm going to use splints. It's exactly the same principle. The only difference is we can't use the splint again. So, just to prove a point, same copper compound, leave it no more than a few seconds just so that can soak into the wood. And just like before, just above the cone of unburnt gas on the hottest part, wait for that to catch, and you see it burns for a little bit longer. And you can see that fabulous green colour there. Now, in class, we will often use this to identify a mystery compound. So I'm just going to go through a few more examples, as each cation will have a different colour. Here we have potassium. Soak it for just a few seconds. And there it's burning a wonderful lilac colour, we say. You can also see my splint starting to catch fire. Now that can affect our results, as some of the cations will burn with an orange flame. So bear that in mind when you are looking at your results.
Following on from the previous video, this is still practical 7 in chemistry, identifying compounds. This is using chemical tests to identify the ions in unknown single ionic compounds. Now, as Sir explained, they will contain positive bits, the metals, which you can do by the flame tests. I'm going to focus on the anions. Now, we know this is lithium, so we already know what the positive bit is. And in Sir's video, you would have seen it change colour. In mine, I actually don't know what the anion is. So I've got a way to find out, okay? The first thing you're going to do is add hydrochloric acid. The first thing you're going to do is add hydrochloric acid. So what I've got here is I'm going to pour some of this unknown solution. I know it contains lithium, but I don't know what else into here. Okay? It's obviously a bit dirty test tube, so let's try that again. Wash it out. I'm going to pour a little bit of lithium in there. Okay, now, the first thing on all of these you should do is you should add hydrochloric acid. So my hydrochloric acid is here. It doesn't have to be very strong. This is 0.5 molar. So I'm just going to add it. If it fizzes, it is a carbonate. And I'm pretty sure nothing happened. So therefore, the anion, the negative part, is not a carbonate. You would see it fizzing. We call that the carbonate test. Kind of self-explanatory, that. For the next bit, I'm now going to add a bit of barium chloride. Now, before you ever add barium chloride, you should always add a bit of hydrochloric acid, just to make sure it's not a carbonate. If it's a carbonate, it would also react with the barium chloride. I've already added the hydrochloric acid, no carbonate. So I'm now going to test it for something else. Adding the barium chloride will test for sulfates. So just put it in. Nothing happened. So again, I still don't know what the anion is. But I know it's not a carbonate. I also know it's not a sulfate. Now I'm going to tip this out and I'm going to start again. Okay, I'm going to tip this out and start again. Okay, again, going to use some of the unknown solution. No, it's lithium, don't know what the anion is. Pouring it in there, putting the lid back on. I'm now going to add some silver nitrate to it. Okay, now I'm going to add some silver nitrate. This is to test for halides. Now, halides is another word for halogens. Now, halogens is when the electron, it's a normal atom in the periodic table. Halides is for when it's gained an electron. Okay, it's become a full outer shell. So I'm going to take my pipette, I'm going to take my silver nitrate. Now, there are 3 halides we are looking for: chlorides, bromides, and iodides. If it goes white, it's a chloride. If it goes cream, it's a bromide. And if it goes yellowy, it's an iodide. And I'm not going to lie, they're quite hard to tell. There is another test to determine that, but you don't need to know that for GCSE. So let me just lob it in. You see it's turned white or a milky colour, okay? Therefore, I would say this is a chloride. Now, if I wanted to test that further to see if I was correct, you could do another test, but again, you don't need to know this for GCSE. Now I know it's a chloride, I know that this solution must be lithium chloride. If I added some silver nitrate and it went a creamy colour, it would be a bromide. If it goes a yellowy colour, it's an iodide. The final thing to mention while we're doing tests is lime water. Lime water detects carbon dioxide. So when I added hydrochloric acid in and it fizzed, we could in theory collect the gas and pump it through lime water and it should go cloudy. That would prove it was a carbonate rather than just detecting some gas. Thank you for listening. That was better, wasn't it?